Okay, good day. I'm Vivek Narsampalli. Welcome to the ACE online platform. Here we're going to spend on the preparation strategy for the subject electromagnetic theory or electromagnetic SIG. This subject is targeted for the students who are preparing for the GATE and engineering services exams. Okay? Preparation strategy for electromagnetics. Okay? Now this subject is there for the ECE, electrical engineering students, as well as for the instrumentation engineering students. Fine? So this is what we're going to do. First we're going to discuss the syllabus and then weightage for the three different branches, for the syllabus for the three different branches, for the ECE, electrical, and for the instrumentation engineering students. And we'll take the syllabus according to the IIT website, and then we're going to put them in order so that we'll understand what is the syllabus, what is the order in which you have to prepare. And then we're going to spend on the preparation strategy, and finally we're going to focus on the reference books. Fine. So let us start with the syllabus of EC, Electronics and Communication Engineering. Then we're going to see for the electrical engineering and then for the instrumentation. So here is a syllabus for the EC. You can just read out. This is a core subject for the EC students. You will find Maxwells Equations. A syllabus starts with the Maxwells Equations, differential and integral forms, and their interpretations, boundary conditions, and wave equation and Poynting vector. This is one module, you can say. The next one is plane waves and properties. Here, reflection and refraction, polarization, phase and group velocity, propagation through various media, skin depth. Fine. And then the third module, you can say, transmission lines. Here the equations, transmission line equations, or you can call it as a telegraphic equations, and characteristic impedance, impedance matching, impedance transformation, S parameters, Smith chart. So this is a third module, you can say. This is a third one. And the fourth one is waveguides, rectangular and circular waveguide. This circular waveguide was not there 2 years ago. It was introduced 2 years ago, the circular waveguides, and there used to be what is called a radar range equation. That was removed. Fine. Radar basics was removed from the electromagnetic theory syllabus. And instead of that, they have introduced the circular waveguide. Because the circular waveguide will give the motivation for what is called one of the most modern mode of communication, what is called a fiber optic cable. Fine. That could be the reason. And then light propagation in optical fibers. Then dipole antenna. Then you can say this as a first module, second one, third one, fourth one, and then the fifth one. Fifth one is a dipole and a monopole antennas, linear antenna arrays. So this is a syllabus which is taken from the IIT website. Fine. So for the electronics and communication engineering students, this subject is very important and it plays a dominant role in your selection process. Fine. See here, let us have some observation on the weightage given for this subject in the different competitive exams. For the GATE exam, just it is average. In the GATE exam, minimum 12 to maximum 14 marks are expected in the GATE exam. In the engineering services paper, including prelims and mains, I'll talk in terms of percentage. 15 to 22% of the weightage is given for this subject. And in the ISRO paper, 10 to 12% of the questions are asked. Fine. So I can say without any agitation, without mastering this subject, you cannot cut a good marks in the GATE exam for the EC students. This is a core subject The core concepts like antennas, transmission lines, waveguides, fiber optic cables are there in this subject. And here this subject starts with what is called a basics of electromagnetic theory, and it focuses more on the waves, transmission lines, antennas, waveguides. Fine. So this is a syllabus. Later we're going to put this syllabus in the order so that which would be very convenient for your preparation. Fine. So this is a syllabus given by the IIT. Fine. Next, let us have a look over the syllabus which is there for the electrical engineering students. Interestingly, for the electrical engineering students, for the instrumentation engineering students, the syllabus is same. The 2 years ago, for the instrumentation engineering students, the syllabus was introduced. Fine. In the modified syllabus. Earlier, there used to be no this subject for the instrumentation engineering students. Fine. So for the electrical engineering students, the syllabus is much concentrated on static fields, electrostatics, magnetostatics, and time varying fields. Fine. And here for the instrumentation engineering students also same. Fine. So let us observe this one. This is common for both ECE as well as, for the electrical engineering students as well as for the instrumentation engineering students. Fine. So let us have a look over the syllabus here. Coulomb's law, it starts with a very fundamental law, and then electric field, intensity, and then electric flux density, Gauss law, divergence, electric field, and potential due to point, line, plane, and spherical charge distributions, and then effect of the dielectric medium, and then capacitance of the simple configurations, Biot-Savart's law. That means this part is something related to the electrostatics. You can say this as a first module, and the second module is Biot-Savart's law. This is related to the magnetostatics. Biot-Savart's law, Ampere's law, curl, Faraday's law, Lorentz force relation, inductance, magnetomotive force, reluctance, magnetic circuits, self and mutual inductance of a simple configurations. Interestingly, Maxwell's equations are not mentioned in the syllabus, but the subject would be incomplete without discussion of the Maxwell's equations. Maxwell's equations give the totality to the electromagnetic theory. Fine. So, and interestingly, the question was noticed in the papers even on the Maxwell's equations as well. Fine. Even though it is not mentioned, one would discuss till the Maxwell's equations while you are preparing for this subject for the electrical as well as for the instrumentation engineering students. Fine. So the weightage is very interesting here in the GATE exam. Minimum 4 to maximum 6 marks are expected. And in the engineering service paper, I'll talk in terms of percentage. Minimum 8% to maximum 12% of the weightage is given. And it is also important for the state service exams. Like an assistant engineer and for all those exams. Fine. And for the instrumentation engineering students, as I said earlier, the syllabus for the instrumentation and electrical engineering is same. It was introduced 2 years ago, but right from the inception, very sizable weightage was given. Every year, 6 marks was asked. Quite interesting. 6 marks in the GATE instrumentation paper. Fine. Okay. So this is the syllabus. There is a huge syllabus for the EC students, undoubtedly, and it is a major contributor for your contribution. It will going to give majorly contribute for your GATE selection as well as for the engineering and even for the ISRO exam. For the electrical and instrumentation engineering students, it is a very fundamental subject. And it has got a very sizable amount of weightage in your exam. Fine. So let us put, this is a syllabus given from the IIT. Let us put this syllabus in the order so that one can understand what's actually the syllabus is, what actually the subject is. Fine. So here, this is how we're going to put the syllabus in the order like this. So the subject starts with the vector calculus. A vector calculus basics are essential to understand the electromagnetic theory. Without beating around the bush, let me be extremely honest. Electromagnetic theory is one of the most mathematical subject, and it requires the proper mathematical background in understanding the things to the greater extent. That is the reason why one should start with what is called a vector calculus and coordinate system. If you can go through the mathematical part in your mathematics, that too especially the vector calculus, that would be a more suggested thing for you. You need to start with the mathematics, especially the vector calculus part. Okay, so these are the very essential things, vector calculus. Of course, not all the vector calculus what you discuss in the mathematics is not required. Some operators like a divergence, curl, gradient, Laplacian operator, dot product, cross product, line integral, surface integral, volume integral, and the conversions among them, which is given by the Stokes theorem and then divergence theorem. All these are required. Fine. So before starting the electromagnetic theory, I strongly suggest you to once go through the vector calculus. Here in my lecture anyhow, we're going to incorporate this vector calculus beginning of the electromagnetic theory, so that we can bring everyone to the same level of understanding and reading. Fine. But if you are doing your preparation, I strongly suggest you to once go back to the mathematics, spend some reasonable amount of time on the vector calculus, so that you're going to be comfortable with this subject. Fine. So especially in this first topic, what you need to do is obviously introduction. As I said, introduction. In the introduction, you can have for your interest, because you all are introduced to the world of electronics through the concepts of voltages and currents. But you can start with the you can understand the scope of a subject. What is the actually reason for studying the electromagnetic theory, and what is the reason behind that, and can't we deal only with the voltages and currents? Just to motivate yourself, you can just read the history of electromagnetic theory. That will give some clear and outline picture of the electromagnetic theory. Okay, fine. You can concentrate on next what is called a vector calculus. As I said earlier, you can take the help of mathematics. You can go back to your mathematics preparation book and just focus on the vector calculus. What are the different operators one should remember? One should know about the vector calculus, like a divergence, and then curl, gradient, Laplacian operator, okay, and then line integral, closed line integral, and surface integral, closed surface integral, and volume integral. And you can do the conversions among these three integrals with the help of the Stokes theorem and divergence theorem. Okay, so looking at these operators, what actually required for the electromagnetic theory is, do not consider them as just as a mathematical operators. Try to understand them physically. Try to have the physical interpretation of the each and every mathematical operator, so that the electromagnetic theory will going to look like a fun of engineering and physics. Otherwise, it will be a burden of mathematics. Okay, that is the reason why I'll strongly suggest for the aspirants to go through these mathematical operators along with the physical interpretation. Fine. Understand what actually the physically divergence is saying, curl is saying, gradient is saying, what is the use of Laplacian operator, and what is the vector Helmholtz theorem. Fine. And what is the meaning of line integral, what is the application of that one, what is the closed line integral, what is the application of that one, what is the flux, what is the net flux, what is the net scalar field, and the Stokes theorem and divergence theorem. Okay, so you should not look at this mathematical operator as just as a mathematical formulas. You have to, one should do a sufficient physical interpretation. Fine. So that is where our interest would be. And then a coordinate system. There are three coordinate systems here. Remember, the coordinate system, this is where actually the students will lose the interest on the subject. They will start feeling this entire subject as an imaginary subject because of the coordinate system, because it's a 3D picture, three-dimensional coordinate system we are having. If you take any textbook for the electromagnetic theory, it will start with the definition of vector, definition of scalar, dot product, cross product. Fine. Cartesian coordinate system, okay. Cylindrical coordinate system, little bit okay. Spherical coordinate system, it will go into spin your head. Fine. So what actually, you will never going to get a direct, interestingly, in our competitive exam, you will never going to get a direct question on the coordinate system. But to what extent we should learn the coordinate system is, you must be in a position to visualize the things to the greater extent. You should know what actually different coordinates are talking about. Majorly we are having a 3 coordinate system here, x comma y comma z, that is a Cartesian coordinate system, and then rho comma phi comma z, that is a cylindrical coordinate system, and then r comma theta comma phi, then it is a spherical coordinate system. And you should know conversions among them, especially a point conversions. There are 2 conversions are there, vector and point conversions. You should focus on point conversions. Conversions, you no need to by heart them. Just if you can able to visualize the things properly. If you know a proper visualization of what coordinates are indicating. Okay, that is sufficient. You just believe me, that is sufficient for our exam. Fine. Okay, so one should have a proper, a clear-cut visualization of the coordinate system. Then one would be more comfortable with the subject. I can say these are the prerequisites to understand the concepts of, or to understand the principles of electromagnetic theory. One is a mathematical background. You should know these mathematical operators. Along with, you should know a physical interpretation of them. And then one should have this a clear-cut, a 3D picture of the 3-dimensional coordinate systems. Fine. And so many sources and resources are available nowadays. You can make a use of them. 3D images are available in the textbooks, and you can take the help of the Google images. Fine. Okay. So this is what you can say this as a prerequisite. And for the exam point of view also, 1 to 2 questions are expected. Every year, you will expect 1 to 2 questions for the EC as well as for the electrical engineering paper. You can take that as a mathematical question, or you can take that as a part of the electromagnetic theory. Fine. Okay. Now we'll move on to the next topic. EM fields and Maxwell's equations. Here where actually the syllabus for the electrical and instrumentation engineering students ends. Okay. So here electrostatics, magnetostatics, and then time varying fields. Okay, this is a syllabus. Now, for the EC students, for the electronics and communication engineering students, they should know some basics of electrostatics. This is not mentioned in your syllabus. Electrostatics and magnetostatics are not mentioned in the EC for the EC students. For the EC students, your syllabus starts with what is called a Maxwell's equations. But this is a syllabus for electrical and instrumentation engineering students. Electrostatics, magnetostatics, and then time varying fields. So after having a proper mathematical interpretation of all these things, one would be obviously comfortable with these concepts. Fine. For the EC students, a detailed discussion of electrostatics, magnetostatics are not required. What is more important is the time varying fields. But interestingly, you can say unfortunately, to understand these time varying fields, one should have a very fundamental knowledge on electrostatics and magnetostatics. Fine. So the EC students need not concentrate much on the electrostatics and magnetostatics. Your interest must be on what is called a Maxwell's equations. Your interest must be on the Maxwell's equations. Your objective must be on Maxwell's equations. So, you should know the Maxwell's equations in the differential form as well as in the integral form. Differential and integral. So to understand some Maxwell's equations and EM phenomena, one should know the basic knowledge. One should have a basic knowledge of electricity and magnetism. You should know what is electric field. You should know what is magnetic field. You should know what is Gauss law, what is Ampere's law. Yes, okay. And then what is Ohm's law in the field form. Some basics are required. So what you need to do is, first look at the Maxwell's equations. I'm talking for the EC students. First what you need to do, you need to look at the Maxwell's equations. Do some reverse engineering. Directly observe the Maxwell's equations. And try to read those statements. Okay? If you can understand from your basics which you have learnt in your high school physics, that is well and good. You can proceed. If you can understand directly Maxwell's equations, that is well and good. You are one of the most fortunate person. You're one of the luckiest person, I can say. Fine. If you can understand after having this mathematical background, EC students can, if you can directly understand the Maxwell's equations, then you have saved some of the time. Okay. Then with that proper mathematics, you can understand the differential form and integral form. And from here you can go. But if you are not in touch with, if you cannot recollect your basics of electricity and magnetism, what you need to do, don't start from electricity and magnetism. What you do, just look at the Maxwell's equations and observe them and think about them. What are the essential basics are required to understand those Maxwell's equations? And only pick those concepts from the electrostatics and magnetostatics. Don't read all the electrostatics and magnetostatics, okay, while you are focusing on the Maxwell's equations, especially for the EC students. Just pick the concepts from the electrostatics and magnetostatics, have an overview, have a look over those things. Once if you do like this, obviously you will be in a position to understand these Maxwell's equations. Okay, this is where actual story begins for the EC students. Now let us talk for the electrical and instrumentation engineering students. This is all the total syllabus for you. Okay, I can say this as a number 2, this is a number 3, number 4. Fine. So in the electrostatics, it will start for the electrical and instrumentation engineering students. It will start with a very basic law. All the things what you have learnt in your high school physics, the same concept will be repeated. But the only thing is with a proper vector calculus approach. As I said earlier, the mathematics is involved. You will talk about what is called a Coulomb's law. Very simple things. You will talk about the Coulomb's law, force between the two charges. You talk about the definition of electric field and the different types of charges, point charge, line charge, surface charge, volume charge. And you talk about the Gauss law. And then you talk about the potential. And you talk about the gradient relation. All simple things. Just know the derivation. For example, if you take one of the most popularly asked question in the GATE exam is electric field due to infinite uniform line charge, or the question on the Gauss law. Let us consider one formula like electric field due to infinite uniform line charge. One should have a look over that derivation. You should know, you should understand how you have got that formula. But the derivation is not required for our exam. You should have an idea about the derivation, but ultimately what you need to remember is the formula. Fine. That is all about the electrostatics. It talks about a charge. It talks about the definition of electric field. It talks about the charge which is at the rest, to put it in a simple words. Fine. Then magnetostatics. Magnetostatics talks about charge under the motion. It will going to start magnetostatics. It will going to start with the Biot-Savart's law. And it will going to start with it will going to have what is called a different types of line charge currents, like a line current, sheet current, volume current, Ampere's law, different laws and different properties. It's all about that. Just you will get some handful of formulas from this electrostatics and magnetostatics. Simple concepts with a proper mathematical treatment. Fine, okay. And finally, you will be having what is called a time varying fields. Fine. So the time varying fields, one of the most important thing is the Faraday's law. For the electrical students and for the instrumentation engineering students also, Faraday's law is one of the most important. You are going to get this Faraday's law in your machines also. And then Coulomb's law, then this continuity equation, and then the Maxwell has suggested something here, then you are going to get what is called a Maxwell's equations. I can say that these three topics will going to have what is called a different law. And properties. Interestingly, those laws are not something new. What you have learnt in your high school physics only, with the proper mathematical treatment. You know the Faraday's law, you know the Coulomb's law, you know the Ohm's law, you know the inductance, you know the capacitance. Fine, okay. So the same, it will going to look like something like a repetition, but with the proper mathematical treatment. One should understand that. Fine. So here where the syllabus for the electrical and instrumentation engineering students will end. Okay. And as I said earlier, for the EC student, they need to focus more on the Maxwell's equations. If you can directly understand Maxwell's equations, that is well and good. If not, just observe the Maxwell's equations and just go back and just go through the things which are required to understand the Maxwell's equations. If you can do like this kind of thing, and if you can identify what are the topics in the electrostatics and magnetostatics are required to understand the Maxwell's equations, and your topic number 2 will be done. Okay, fine. Here also, for the instrumentation and electrical engineering students, they will going to get a major contribution from here. Minimum 3 to 4 marks are expected for the EC students. Yes, just it is a rough estimation. You will get some minimum 2 to maximum 4 questions. Maximum 3 questions you can say from here. For the EC students, you can expect only 1 to 2 questions from here on the Maxwell's equations. Fine. In the recent time, there is no direct questions on the Maxwell's equations for the EC students. Fine. So first proper mathematical treatment, basics, and then for the EC students, focus will be on the Maxwell's equations. For the electrical and instrumentation engineering students, the focus will be particularly with the detailed discussion of electrostatics, magnetostatics, and then time varying fields. Clear? Okay, fine. So this is where the syllabus for the EC and instrumentation engineering students ends. Fine. And then let us focus on the EC students. We'll move on further. And for the EC students especially, you are having actual syllabus starts from here, I can say in that way. The core part of the syllabus starts from here. EM wave propagation in unbound medium. You will going to have what is called a general wave equation this year. In the 2022, there was a question on the general wave equation. And we will going to talk about what is called a uniform plane waves. Uniform plane waves will have some special behavior, special properties. And then we'll talk about the different properties of them. What is called a characterization of the medium into no loss, low loss, high loss. Okay, fine. And then a polarization. In the polarization, we talk about what is called a time behavior of the electromagnetic wave. This talks about the magnitude, different parameters like a attenuation constant, phase constant, intrinsic impedance, velocity, different parameters in the different mediums. We'll going to understand first wave phenomena, wave equation, then we'll going to do the characterization of the medium. You need to focus on that. Next, polarization. I can say among all these topics, one of the most easiest topic is this polarization, and you can easily score the marks on that, and you will find some shortcuts there. Fine. And the pointing theorem, or you can get pointing vector. That means it talks about the power which is carried by the electromagnetic fields or electromagnetic waves. Fine. And then the reflection and transmission coefficient. Here, before this one, you should have the wave equation, a wave equation for arbitrarily directed wave, making some angle with respect to x-axis, y-axis, z-axis, a reflection and transmission coefficients for the perpendicularly polarized wave as well as for the parallelly polarized wave. And then you are having what is called some special cases like a total internal reflection and Brewster angle. What is the condition for the total internal reflection? You can say total reflection. The Brewster angle will give what is called a condition for the total transmission. Okay. So the problem with these uniform plane waves or EM waves is, you will have a very lengthy derivations. Now let me give one simple example. Suppose if you want to show that the electromagnetic phenomena in the free space will be something like this. Electric field is like this, magnetic field is like this, a direction of propagation is like this. Or to put it in a simple words, electric and magnetic fields are perpendicular to each other and their magnitudes are changing in the third perpendicular direction. Or in other words, electric and magnetic fields are perpendicular to each other and they're propagating in the third perpendicular direction. To prove this simple statement, it takes a minimum 10 to 15 minutes of derivation. Okay? So always remember one slogan here. The analysis is lengthy, to be very frank. Analysis in the electromagnetic theory is a very lengthy, but conclusions are very simple. Okay? The conclusions here are only two wave equations, electric wave equation and a magnetic wave equation. Here a uniform plane wave, why it is called uniform, why it is called plane, and why, what is the wave format. 3 conclusions. Here 2 conclusions, here 3 conclusions. Here the parameters, something like a attenuation, a phase constant, intrinsic impedance, phase velocity for the 3 mediums. You can put it in the box. And here the polarization. You should remember the conditions for polarization: linear, circular, elliptical. And then a pointing theorem. What is the pointing theorem? What is the pointing vector? What is the average power? What is the average power density? Only 2 conclusions. Here a reflection and transmission coefficient for perpendicular polarization, parallel polarization. 4 conclusions. Here condition for total internal reflection and the formula for critical angle, condition for Brewster angle and formula for Brewster angle. See, just only a handful of conclusions here. Here 2, here 3, here 3, here 3, here 2, here 4, here 4. Conclusions are very simple in the electromagnetic theory. As I said earlier, these are conclusion, but to prove this one, it takes 10 to 15 minutes. And if you directly focus on the conclusions, that will not make any sense. That is the reason why one should go through all the analytical part. Then only you can easily remember the things and you can feel and you can sense the subject. Fine? Okay? Okay, fine. So this is all about what is called electromagnetic EM wave propagation. Here also 1 to 2 questions are expected. I'm talking gate point of view. And then this is an electromagnetic wave in the unbound medium. That means if there is no boundaries, this would be the behavior and these are the things we're going to have a discussion. And this is where you need to focus. And then the waveguide. Fine. That means topic number 3 focuses on electromagnetic wave in the unbound medium. There is no boundaries at all and the wave is traveling. But if you want to trap the electromagnetic wave, if you want to guide the electromagnetic wave through some structure, you would have seen nowadays one of the most popular mode of communication is the fiber optic cable, where the frequencies are involved in terms of terahertz. These waveguides are used, literally the waveguides are nothing but a hollow metallic pipe, something like a water pipe what you use. These hollow metallic pipes are used to transmit, are used to trap, you can say, are used to guide the electromagnetic waves in the gigahertz frequency range. Fine. Only 2 kind of waveguides are mentioned in your syllabus, a rectangular waveguide and circular waveguide. But this year, there was a question on even on the parallel plate waveguide. That is the reason why I have included that one here. You should not treat the parallel plate waveguide as a separate thing. A rectangular waveguide is something like this. It will have a rectangular cross section. One can easily learn the parallel plate waveguide from the rectangular waveguide. The only thing is you need to remove this set of plates. Just remove this one, then it will become a parallel plate waveguide. Okay, that is the approach one should have. Don't treat this parallel plate waveguide as a separate thing. It's a special case of a rectangular waveguide. Fine. So in this all 3 waveguides, what are the one should understand and one should remember for your exam? Identification of mode. Mode identification. identifying the mode from the diagram and from the expressions, and from the diagrams. Okay, yes, that is the one type of questions are expected. The other one is cutoff frequency. It's a very important. If you do not know anything about the waveguides, and if your luck is good, and if you remember the cutoff frequency formula, you can directly handle that without knowing anything about this one. One of the most important, I can say, cutoff frequency and dominant mode, one can say, other one is, and then power calculations, and dominant mode here, dominant region also. See, there are some different modes here, like a TE mode and TM mode in the rectangular waveguide, in the parallel plate waveguide, even in the circular waveguide. When the wave is traveling in the unbound medium, it is TM wave. There is no longitudinal component. But if you consider the wave propagation inside the waveguide, there will be a TE wave and TM wave. And the expressions for getting the expressions for the TE and TM wave, there is a very lengthy derivations are involved. That is where the students will lose the interest on the waveguides. But the conclusions are very simple. You believe me, out of 3 hours of derivation, you will going to get only 4 conclusions. The first conclusion would be the waveguide do not support TEM wave. The second one is the nature of the TE. The third one is nature of the TM. And the fourth one is the nature of the field. And if you can analyze the things, just understand the gist of the story. And ultimately, if you can figure out what actually required for and relevant for our competitive exam, then that would be sufficient for our discussion. Clear? Yes? So one should focus on what is the nature of the TE wave, what is the nature of the TM wave, and how the fields are. We will be solving the wave equation, we will be having a boundary conditions, very lengthy derivations you will going to have. We are going to use what is called a variable, there will be what is called a variable separable method. Okay, but your ultimate observation should be on the conclusion part. You should go through all the derivation, but ultimately you need to make a note of those conclusions. And that conclusions will going to help us in identifying the modes, mode identification, cutoff, and that is the heaviest part in the waveguide you have. And the rest of the things are very simple. Cutoff frequency, dominant mode, dominant region, power calculations, and then different parameters you are having what is called a intrinsic impedance, and then velocity, and then wavelength. Okay, fine. In the year 2020 also there was a question on parallel plate waveguide. Fine. Okay. So one question is guarantee. Minimum 2 marks are guaranteed from here. Clear? Okay, fine. This is all about the waveguides. Okay. So waveguides I can classify into 2 parts. One is a wave theory part, other one is a wave theory. In that you will going to have a solving the wave equations, boundary conditions, variable separable method, and all the story. And the rest of the part is we will going to treat the waveguide as a high pass filter. Rest of the part is very simple. When you treat the waveguide as a high pass filter, you will going to have a cutoff frequency. You will going to have what is called a waveguide parameters, a power calculations, and all those simple things. Fine. So that is all about the waveguides. Next, let me turn the page here. Next, we are having a transmission lines. I can say, one would say, transmission line is one of the most simple thing. It is a more scoring topic in entire electromagnetic theory. But only problem with the transmission lines is it is having a very huge number of topics, a very lengthy one. Too many things need to be remembered here. And interestingly, it is a twin, I can say. It has got lot of resemblances compared to the electromagnetic theory. So what engineers have done here the transmission line will going to understand in terms of voltages and currents. It will going to look like just a repetition of the electromagnetic theory with some extra topics. It is a scoring one, but it is a lengthy one. Fine. So your transmission line, you should focus on what is called a primary and secondary constants, a reflection coefficient. Here most of the students will remember the reflection coefficient at the load, but they'll forget the other formula. What is a reflection coefficient at any point on the transmission line? Okay, so 2 points you have to, one should remember the reflection coefficient at the load and as well as a reflection coefficient at any point on the transmission line. Clear? Yes. And impedance matching impedance at transformation relation. What would enjoy in doing this one really? You have to concentrate on the different lengths like a lambda by 2, lambda by 4, lambda by 8 and matched load. And then a characterization of the transmission line. Here there are 3 characterizations: no loss, low loss, high loss and then distortionless. No loss, low loss, high loss and distortionless. We do not have much discussion on the high loss transmission line, but what is more important is the distortionless transmission line. You will find lot of resemblance of this transmission line analysis with the electromagnetic theory. One would suppose if you learn the electromagnetic theory properly, that means uniform plane wave or EM wave propagation in the unbound medium, there will be a lot of resemblances here. And then what is called a standing wave ratio. Here, because of the incident and reflection, there will be a voltage standing wave and current standing wave. Voltage maxima, voltage minima, current maxima, current minima, and we're going to have definition of what is called a voltage standing wave ratio. Location of voltage maxima, location of voltage minima, location of current maxima, location of current minima, distance between maxima to the maxima, distance between minima to the minima, maxima to the minima, minima to the maxima. All these things one should focus. And the next, there are some, I can say these are some of the miscellaneous topics, but why I am calling them as a miscellaneous topics? The questions asked from these ABCD parameters, power calculations on the transmission lines are very rare. Once in a blue moon, you will find the questions on these concepts. 5 years ago, 6 years ago, there was a questions on these concepts, but there are the questions. So one should not skip any topics. That is the reason why I am calling them as a miscellaneous topics. Only because of their frequency of occurrence. Power calculations on the transmission line, ABCD parameters, as I said earlier, these are occurred once in the blue moon. This one and this one. And then this one also, transients on transmission line. It is a pulse excitation. It is mentioned. Pulse excitation also you can say, a transients on transmission line. This is also very rarely asked topic. And the Smith chart. So what is no one will going to give the Smith chart in the examination hall and do some calculations on that and ask you to do some calculations on that. But when it comes to the Smith chart, in the recent times also there are very good questions are asked on the Smith chart. What must be your focus on the Smith chart? You must be in a position to identify all the landmarks on the Smith chart. What is a point on the uppermost half of the Smith chart? What is the upper half of the Smith chart? What is the point on the lowermost half of the Smith chart? What is the point on the lower half of the Smith chart? What is the point on the left extreme of the Smith chart? What is the point on the right extreme of the Smith chart? What is the point on the center of the Smith chart? What is the clockwise rotation on the Smith chart? What is the anti-clockwise rotation on the Smith chart? What is the pi degrees rotation on the Smith chart? What is the 2 pi degrees rotation on the Smith chart? What is the VSWR circle? What is the location of V maxima, V minima, I maxima, I minima? So you must be in a position to figure out all these things on the Smith chart. I will call them as a landmarks on the Smith chart. Okay. So by seeing at the Smith chart, one should know what is the constant resistance circle, constant reactance circles, and all the things what I have listed out. So here on the Smith chart, theory questions are expected. Fine. So you'll draw some rough diagram of the Smith chart in the paper, and you will identify some points like A, B, C, D, and you'll ask for what this A is indicating, B is indicating, C is indicating. Fine. Don't by heart the things. While you are learning the Smith chart, you should take some downloads from Smith chart and you take that as a reference and try to understand how it has developed. Okay, fine. So first understand what is a constant resistance, constant reactance, and clubbing these two things will give what is called a Smith chart. And finally what is called a scattering parameters. Fine. So you are having a different two-port network parameters in your circuit theory, but these scattering parameters are best suited for the high frequency junctions. You can call them as a micro junctions. In your circuit theory, you define the parameters like a Z parameters, Y parameters, ABCD parameters, G parameters, H parameters, either by performing what is called an open circuit or short circuit. But here in the scattering parameters, what happens at the high frequency is it's the realization of the open circuits and short circuits are difficult. That is the reason why the scattering matrix comprises of what is called a reflection and transmission coefficients. And you will realize these scattering matrix parameters by performing what is called a matched termination. That is the difference between your circuit theory parameters and S parameters. Fine, okay. So I would say these transmission lines is one of the, if you can really concentrate on these topics, one can easily score the things. Just it would be just a repetition of electromagnetic theory, but you will find voltages, currents, and you will be much more comfortable. Fine, but the only thing is it is a little bit lengthy one. Too many concepts are there. Fine, give the equal priority to all the concepts. Question can be from anywhere. Fine, so last one is the antenna theory. Most of the students are not comfortable with the antenna theory. The only reason is they do not follow the notations properly. I'll repeat my words. They do not follow the notations properly from the antenna theory. In the antenna theory, that is the reason why they are not comfortable, especially the angle notations. Fine. So I can say directly, one of the most important, you can check out past 5 years paper, you will find one question on the antenna arrays, especially the two element array. Here goes what is called, you will find some theory, definition of antenna, what is the job of the antenna, how do you get the radiation, how do you get the effective radiation. That is where you need to focus. And then Hertz dipole. What is the Hertz dipole? Your discussion starts with the Hertz dipole. Hertz dipole will give the motivation. Hertz dipole is a simple current carrying conductor, a small size one. Your antenna theory you have to start with the Hertz dipole. As I said earlier, to find out the fields radiated from the Hertz dipole, there will be some 5 to 6 pages of derivations will be there in your textbook, any standard textbook. Just leave that derivation. Understand the essence of the derivation, what are the steps of the derivation. And ultimately, you need to focus on the conclusions. And you need to interpret what are the fields radiated from the Hertz dipole. What is the power? What is the power radiated from this one? What is the polarization? And what is the radiation pattern? Okay, and what is the radiation resistance? These are the things you need to focus from the Hertz dipole. Okay, power radiated from the Hertz dipole, radiation resistance, radiation pattern, and polarization. Okay, the Hertz dipole, your theory, antenna theory starts with the Hertz dipole. Some of the textbooks, unfortunately, they'll start with the antenna parameters. Don't go in that order. Without knowing one of the antenna, without knowing the terminology of the antenna, how can you understand the antenna parameters? Isn't it? Fine. So what I strongly suggest is start with the Hertz dipole, okay, and then you can later go to the antenna parameters. So Hertz dipole also give the motivation to the practical antennas. Just it is theoretically a small length, a current carrying conductor. If you can understand and if you can develop the analysis for the small current carrying conductor, you can extend it to any arbitrary length through the concepts of integration. So that is the idea involved in understanding the antenna theory, starting with what is called a Hertz dipole. Clear? Okay. Then we're going to have what is called a dipole antenna. A dipole antenna is a practical antenna. There will be a half wave dipole, there is a dipole, and what is the field radiated from this one, what is the power of that one, what is the radiation pattern for the different lengths of the antennas. Fine. And then we're going to have what is called a antenna parameters. There are different parameters are there. Suppose if you want to compare the two antennas, one need what is called a antenna parameters. There are different parameters like a half power beam width between first nulls, direction of maximum radiation, and directive gain, power gain, directivity, effective aperture, efficiency, polarization efficiency factor, side lobe level. These are too many for antenna parameters are there. Just focus on direction of maximum radiation, half power beam width between first nulls, directivity, effective aperture, directive gain, efficiency and power gain. So these are the things one should focus, and polarization efficiency factor. If you open any textbook, there are around some 20 parameters will be there for the antenna parameters. Don't focus on all those things. Just list out what I spoke, what I have listed. Just focus on those things. I'll repeat again. Half power beam width between first nulls, directive gain, directivity, power gain, efficiency, effective aperture and polarization efficiency factor. So these are the parameters one should focus for your exam. Fine. Then there are practical antennas are there. There are so many practical antennas are there, but you need to confine yourself only for your exam. One antenna is one of the practical antenna. One of the most practically used antenna for the broadcasting application is a λ/2 length, or it is also called half wavelength antenna. Fine. So half wavelength antenna, and there is one more antenna what is called a monopole antenna. So these two antennas you should know. What is the monopole antenna? What is the different characteristics of the half wavelength antenna? And one should also know what is called a image theory. Fine. What it is? Image theory. What is the image theory? Suppose if I place my antenna horizontal to the perfect conductor, vertical to the perfect conductor, and something like this, something like this, something like this, with the different orientations, and what this a perfect conductor will going to offer. So one should know what is called a image theory. Before going into the monopole and discussion, understanding of the monopole antenna, one should know what is called a image theory. And even this image theory will also help you in antenna arrays. Okay, fine. So antenna arrays, finally. As I said earlier, before starting this antenna theory, one should go through what is called a spherical coordinate system. Okay, I'll talk about that. Let us focus, you have to finally focus on the antenna arrays. There are 2 element array and n element array. So focus more on the 2 element array. There are more chances of getting questions from the 2 element array compared to the n element array. In the n element array, you will have some approximated formulas are there. In the GATE exam, on those approximate formulas, the questions were not noticed, like a approximation formulas for half power beam width, first null beam width, directivity. For the engineering service exam, just before 2 to 3 days before that one, just by heart those formulas and you can go. Fine. Those are memory based formulas. Okay. But the analysis involved for the 2 element array and even for the n element array also. So your focus will be more on what is called a 2 element array. Fine. So even though you would have learnt what is about in the first topic itself, you have to cover what is called a coordinate system. But just before starting with this antenna theory, what one should know is they must go through what is called a spherical coordinate system. We'll be using what is called a spherical coordinate system. Just to review the spherical coordinate system before starting the antenna theory and follow the notations properly. Okay, most of the students are not comfortable with this antenna theory because they do not follow the notations, angle orientations properly. They'll confuse with this spherical coordinate system and the antenna array axis. Okay, so one should have a clear-cut understanding on the coordinate system, especially the spherical coordinate system, before starting with this one. And you should skip all the big derivations. Just you need to focus on the end results of the radiated fields due to the Hertz dipole and radiated fields due to the dipole antenna. what is the radiated, what is the electric field radiation due to this one, what is the electric and magnetic field radiation due to this one, what is the electric and magnetic field radiation due to this one. And you should know, you should remember all the definitions of antenna parameters, and then antenna arrays, one should know the analysis. How to analyze the 2-element array, how to analyze the n-element array. Fine. Let me have some rough overview on the things what we had in this session. So as I said earlier, this is a syllabus. I have kept this one in the order so that you will be comfortable. So this is the EC syllabus, this is the electrical engineering syllabus, this is the instrumentation. Electrical and instrumentation is the same. Interestingly, right from the inception, there was a 6 marks was asked for the instrumentation engineering students. So start with the mathematics and try to have the physical interpretation of these operators, and try to get a perfect 3D visualization for the coordinate system. And the rest of the things will be a fun of engineering and physics. Otherwise, the subject entirely looks like a burden of mathematics. Fine. Then, EC students must concentrate on the Maxwell's equations. If you cannot understand them directly, just go back to the electrostatics and magnetostatics. Okay? For EC, for the electrical and instrumentation engineering students, just understand the derivations and remember the conclusions. Fine. So all the simple things what you would have learnt in your high school physics, but with the proper mathematical treatment. You're going to have what is called a laws and properties, differential form, integral form, and vector calculus. Clear? Okay. And EM wave propagation in the unbound medium. Conclusions are very simple, approach is lengthy. Okay. And then there are 3 things here: waveguides, parallel plate waveguide and circular waveguide. You can classify this one into the 2 parts. One is a wave approach, other one is a high frequency, high pass filter approach. The wave approach is little bit complicated, even I too accept, but make a conclusions of that. What is the TM wave, what is the TE, TM, and what is the nature of the fields, and after that you will going to start treating your waveguide as a high pass filter and just list out all the formulas. And then transmission lines. It is a relatively very simple topic, but the lengthy one. And then you have antenna theory. You have to take one precaution. You need to follow the notations properly. And before starting this antenna theory, one should go back and revise and review this spherical coordinate system. And what must be our strategy? See here, obviously you need to make a note. You need to prepare a notes with the full of derivations, analysis, and all the story. And then you should have what is called a short notes. As I said earlier, electric field due to infinite uniform line charge will have some lengthy derivation. You will have a line charge and you will take one piece and you will integrate it from minus infinity to infinity, and finally you will going to get a formula E is equal to rho L by 2 pi epsilon. Just a formula. You have to make some short note. For the EC students, just as I said, I have given one simple example. Electric field, magnetic field, direction of propagation. Just to prove this one, you will have some 10 minutes of derivation. So skipping all those derivations, all those analysis, one should make a short notes. Okay, for your quick reference. Make it on the A4 size paper and later you can update them. Okay, fine. And then you should have to practice questions here. Okay, collect the questions from the various mediums, from the textbooks and all the things, whatever you like, from wherever you like, and then obviously you should solve the previous gate questions. And then previous ESC conventional. Obviously one should solve the previous gate questions so that you can understand what is the level of questions, and you can even estimate yourself also. And one is something new point I have added here, ESC conventional paper questions. Conventional questions are good, ESC conventional questions are good. And even by solving and looking at the solutions, if you could not able to solve them and looking at the solutions also, you learn some new things. You can upgrade yourself, fine. So anyhow, you're going to write the short notes. And after solving some ESC conventional papers, you will get to know some new things. You can upgrade yourself. You will be looking the subject in a different manner that will going to change your perception, and you will get to use it to be some new terminology, new questions. Okay, so I'll strongly suggest you to solve this one also, ESC conventional paper. Anyhow, you need to take the, and at the end, you need to take the test series very seriously. Okay, fine. And then, so this is a flow of your preparation. You need to start, you need to make a note, you need to make a short notes and solve some questions from the, collected from the different sources. And then you have to focus on the previous gate and ESC conventional paper. Very good questions are there, even in the conventional and test series, ultimately. Fine. And obviously, what are the books for the reference? This is for the EC students. This is for the electrical and instrumentation engineering students. There are too many good books are available for the this subject, but here we are not here to do research. Our main aim is for the selection. Fine, scoring cutting a good marks in the GATE exam. Fine. So I'll strongly suggest for the EC students, electrical and instrumentation engineering students. This is a book they need to follow. Elements of Electromagnetics by Sadiku. Fine. This book will going to start with the vector calculus, electrostatics, magnetostatics, Maxwell's equation, all that story. And there will be a wave sign also will be there. But for the EC students, I strongly suggest you to download or purchase this book. Okay, Electromagnetic Waves by R.K. Shevgonkar. This books concentrate more on Maxwell's equations. It discusses some little basics from the electrostatics and magnetostatics. This book do not concentrate much on electricity, magnetism. It will go. This book focuses more on Maxwell's equations, and sufficient basics of the electricity and magnetism are provided in this book. But still, if you feel that the basics given on the electrostatics and magnetostatics are not sufficient, then go back and refer this book. Okay, fine. Okay, so EC students, this is the best suited book for our competitive exams. Okay, that is what I feel. So this book starts with what is called a transmission lines, interestingly. And then Maxwell's equations, uniform plane waves, waveguides, and then antennas. A very good book, best suited for our competitive exams, and very good collection of numericals also. Fine, example numericals also provided, and here also. And then there is one more book, a very good collection of solved problems are there in this book. 2008 plus solved problems in electromagnetics by Syed A. Nazar. This book is there. This book is for ECE as well as for the electrical and instrumentation engineering students. Okay, fine. So electrical and instrumentation engineering students, they can read, they can solve the questions up to Maxwell's equations. For the EC students, they are having a good questions on transmission lines, waveguides, as well as on the antennas. Fine. Okay. So I strongly suggest for the EC students to read this book, Electromagnetic Waves by R.K. Shevgonkar. Very simple language, best suited for our competitive exams. And for the electrical and instrumentation engineering student, this book. Fine. Okay. So this is all about the preparation strategy, and this is all about the subject, topics, and the syllabus. Okay, fine. All the best. I'll wish you very success. Hope you'll all going to make the ACE online platform as a part of your success story. Thank you.